This video is a run through of the solution for 2015, paper 2, question 9. So part A, first of all, we're given the information that we have the heights of a random sample of 1,000 students, and we want to categorize what type of data we're looking at there. So height is data that you measure, and measurable data is numerical continuous data. And our reason is just that height is measured, so it's numerical continuous data. The next question is a grouped frequency distribution table, and it's just giving us the heights of the girls, but it's not giving us their individual heights. It's breaking them up into groups or intervals. So, for example, I have the interval 145 to 150, and there are 15 people that fall into that particular range. Now, you'll notice in the question that they say to estimate the mean height of the girls. That doesn't mean that we guess it. What it means is that when we calculate the mean height, that it will be an estimation, since we don't know the individual pieces of data for every single individual person. So my calculation requires a little bit of estimation. And the first thing that I'm going to do is I'm going to work out my mid-interval values. So I've just copied the table out here, and I've got my heights and my number of girls, but before I can begin to calculate mean, I have to get my mid-interval value. Now the mid-interval value is just the middle of each of these intervals, and the easiest way to calculate your mid-interval is to take the first value and the last value from an interval and add them together and divide by 2. So in the case of the first interval, you'll have 147.5. So calculate now yourselves what each of the mid-interval values are. Pause the video, do that, and then play again to see if you're correct. So here we can see our mid-interval values, and in this particular case they're nice and regular. They go up in 5s each time. Just be careful not to get kind of lulled into a false sense of security about a pattern like that. The reason that this happens is because all my intervals have a width of 5, and that won't always be as standard in any questions. So just make sure that you're kind of keeping your eye open, that you have the correct mid-interval, and if you're not sure, just do your quick calculation to see that you're correct. So I've labelled my mid-interval row as X and my frequency row as F. At this point, I'm going to pretty much ignore the original height row for the calculation for mean. And at this point, you've got 2 ways of calculating your mean. You can do it out on paper, or you can use your calculator. And I'm going to do it out on paper first of all, and then talk about how to do it on the calculator. So if you're doing it out using the formula, you want to use the formula summation fx over summation f. So what this means is that you literally take each individual frequency value, so this is my f row, and multiply it by its mid-interval value. So that's f by x. Do that the whole way along your table, and then this guy just means add them all up. So the top row of my calculation is going to look like this. And then on the bottom, I have to sum f. So that just means take all my frequency values and add them up. So these are my frequency values. So I'm just going to total those up in the bottom of my calculation, like this. And then off I go to my calculator and work out the top and work out the bottom. And I get 82,215 over 500. I'm not surprised about the 500 here, because they had said earlier in the question that my sample of 1,000 students had 500 girls and 500 boys. So these are my 500 girls. And when I calculate out my final answer, it comes out as 164.43. And again, don't forget my units, which are centimetres. Now, of course, I can just use the calculator straight off to calculate mean also. If you're going to use the calculator, the first thing that you should do is you should hit Shift 9 to reset your calculator. 3 equals AC, and that just gets rid of any previous data that might be stored in your calculator. Then I want to turn on my frequency. In the case of this newer calculator, I want to press Shift, Setup, down arrow, 1 to turn on the frequency. Then I'm going to go to Menu, 2, 1. Now I'm going to enter my pieces of data. So let's have a look. I want to enter my mid-interval value, and I want to enter my frequency also. So I'm putting in 147.5, I'm pressing equals, and then I'm going to change the frequency to 15. I'm going to keep doing this for all my subsequent values. So I've got 152.5, press the equals after it, and then change your frequency to 48. Press an equals to register that also. 157.5 equals, frequency is 80. 162.5 equals, frequency is 112. 167.5 equals, frequency is 125. 172.5, press the equals, 81 is the frequency. 177.5 equals, and 29 is the frequency. And 182.5, sorry, I need to edit that. 182.5 equals, and the frequency is 10. And when I have the last one entered and its frequency and I've pressed equals, I'm then going to press AC to clear my screen. Don't worry, the information isn't gone, it's still stored in the memory of the calculator. So on this newer Casio calculator, to get my calculation, I'm going to go to Option, I'm going to select 2, and then it's going to give me a list of all my different available values. So in this case, I can see that at the very top of my list, X bar equals 164.43, which is the same as we had calculated on paper. Again, don't forget to include your units when writing your answer. With this newer Casio calculator, I can also straight away see my standard deviation if it was required as 7.754. If you want to know how to do this on the older Casio calculator, go to Teams and follow the link in the statistics page. B part 2 is asking what the largest possible range of the heights might be. So, like I said, I don't know the individual values of the girls' heights, but I do know that the people in this particular interval have heights between 145 and 150. So it's possible that I might have somebody with the lowest available height of 145. And in this top interval, I've got a range of 180 to 185. So it's possible that somebody is coming up on 185 centimeters. So the biggest possible range, so is my biggest possible available value in my top interval minus my smallest available value in my lowest interval on my table. And in this case, that gives me 40. And again, don't forget to include your units. Part 3 tells me that 164.5 centimetres is the median height of these girls, and it asks me to explain the context of this. So median is just the middle value of ordered data. So really what it tells me is that 50% of the girls are below 164.5 centimetres and 50% of the girls are above 164.5 centimetres. And of course, 50% of my 500 is 250. Question C part 1 asks me to state what percentage of the group falls into each interval. They've already filled in 22.4 and 25 for me here. At this stage, I already know that the full group is made up of 500 girls. So to find each percentage, all I'm doing is putting the number or the frequency of girls in each interval over 500 and timesing it by 100. So for example, for the first group, it's going to be 15 over 500 times by 100. And that's going to be 3%. So I'd fill 3 into that part of my table. So here I see the individual calculations for the percentages. I work those out and fill them in to the spaces on the table. And I can easily check to see if I'm correct by just totting up my percentages here and checking, do they come to 100%? Am I representing the whole group? And they do. C part 2 asks me to draw a histogram for the heights of the girls. Just watch out though that it asks me to show the percentages of girls in each height category. So I'm going to be using the information that I just calculated in the last part of the question. And our diagram should look like this. Part 3 of the question asks us to look at the 175 to 180 centimetre category for the boys and the girls and see if we can support the claim that there are roughly twice as many boys as girls in the 175 to 180 category. Well, when we look at the diagram for boys in the exam papers, the 175 to 180 category is landing just below 12%. So let's say 11.5 approximately %. And if we look at our table and our diagram for the girls, we can see that in the 175 to 180 category, we've got 5.8% of the girls. So 11.5% is roughly twice as big as 5.8%. So we can say that, yes, the histogram supports the claim. Part 4 says that Mary examines both histograms and decides that there are more tall girls than tall boys, and we want to see, do the histograms actually support this claim? Well, the problem with the histograms is that they only tell us what percentage fall into each category. They don't tell us the individual exact heights of the people. The other issue is that Mary hasn't defined what she means by tall. So in this particular instance, I would say that no, the histograms don't support this analysis of the information, for the reasons that, first of all, tall has not been defined, and even if it was, the individual heights are not available to us. Next we have D part 1. I'm told that the boys' heights are normally distributed, and that allows me then to use the empirical rule to decide what percentage of their heights fall into particular categories. So if you recall, the empirical rule states that 68% of the data will be between plus and minus 1%, one standard deviation, I should say. 95% of the data is between plus and minus 2 standard deviations, and 99.7% of the data is between plus or minus 3 standard deviations. Now, I'm interested in the 95% category. So I'm going to want to take the mean, add on 2 standard deviations, and subtract 2 standard deviations, and that will give me my range. So first of all, I'm going to add on 2 standard deviations, and that's going to bring me up to 184.5 centimetres. And then I'm going to subtract 2 standard deviations, which brings me down to 148.9 centimetres. And the question said, find the interval that will contain 95% of the heights. So the interval in question is from 148.9 up as far as 184.5 centimetres. Finally, D part 2, we're told that the standard deviation of the girls' heights is 7.7 centimetres and the boys' heights have a standard deviation of 8.9 centimetres, and we're asked to interpret this difference in the context of the data. So first of all, remember that standard deviation measures spread, and the bigger the standard deviation is, the more spread out the data is, and the smaller the standard deviation is, the less spread out the data is. They'd also like us to interpret this difference in context, so we want to actually refer to this particular scenario. Well, we've already calculated that 95% of the boys' heights, and that calculation was based on standard deviation, are in the interval 148.9 to 184.5. We can do a similar calculation for the girls, and we would see that 95% of the girls' heights are in the interval 149.03 up as far as 179.83. I've just done this by taking the mean that we calculated earlier in the question for the girls and taking off 2 standard deviations, so 2 7.7s, and adding on 2 standard deviations. And if we look at the spread across which each of those intervals exist, we can actually see that for the boys, from 148.9 to 184.5, there's a spread of 35.6. So in the case of the boys, there's a spread of 35.6, and in the case of the girls, there's a spread of 30.8, which again just reinforces that idea that since the girls have a smaller standard deviation, they've got a smaller spread, and since the boys have a bigger standard deviation, they have a bigger spread.